Today we'll start a new chapter, that is chapter number 6, Fundamental Operations on Algebraic Expressions and Identities. In class 6, in class 7, you have learned about the algebraic expressions. So what happened in case of the algebraic expressions, there should be combination of both numbers and the variables. So let me say twice x plus 5. This is a simple example of algebraic expression. Here I find both numbers and the variables. Here variable means this x, this is variable, and this 2 and this 5, these are all constant. This is simply an algebraic expression, and here what happened, let us remind some of the important terms and which we might use in the later part of the chapter. In this twice x, what happened, these 2 is a constant of course, but for this x, this 2 is called the what? Coefficient of x. 2 is the coefficient of x. And then let me say minus thrice x. What is the coefficient of x? Minus 3 is the coefficient of x. Similarly, when I write here minus 7y, what is the coefficient of y? Minus 7. So these are the things that you have to know. And now let me tell you about the terms. Let me write here one algebraic expression: 7x plus 8y plus 9. So when we talk about the terms should be always separated by either plus or minus. Okay, let me say here 9. It should be always separated by either plus or minus. So when we see this algebraic expression, we find here 3 terms. What are the terms? The terms are 7x, the next term is minus 8y, and the last term is 9. And particularly, out of these 3 terms, one term is without any variable. That means the particular term is free from variable. What is that? That is 9. Those terms, or any term without any variable, that term is what we call constant term. Constant term. Okay, don't forget, terms should be always separated by either plus or minus. Okay, and the constant term means the term without any variable. So after this, let us remind like terms and unlike terms. Let me write here any 2 terms here. 7x and this is 6x. Are these 2 terms like or unlike? So in case of the like, what happened, we have to compare their variables. Okay, let's see how we are going to compare. In this term I find here x. In this term also I find here x. So there is x, there is x. Okay, and what about their power? Here the power of this x is 1, and here the power of this x is 1. That means they have the same type of variable, and moreover they have the same power again. For this x the power is 1, and for this x the power is 1. That means these 2 are like terms. So this is like terms. Okay, I'll give you another example. 8x to the power 2, 7 minus 7x. We don't need to compare about these numerical coefficients. Let us see here x, and here is x. Now I find here xx, same type of variable, but let us see the powers. Here the power of x is 2, and here the power of x is 1. That means they have the same type of variable, and their respective powers are not same. Here is 2 and here is 1. That means they are unlike terms. Okay, another example, let's see. Minus 6xy, 8xy. I find here both x and y. X, y. And what about here? Here also I get here x and y. Okay, now let us see the compare of x first. Here x, the power is 1. Here x, the power is 1. And what about y? Power 1, power 1. That means they are like terms. D. Minus 8xy. Then here 6xy square. Now let's see whether these 2 terms are like or unlike. I find here x and y, I find here x and y. Okay, the first process is done. What about the second? Let us see the power of the x. Here I find 1, here I find 1, fine. What about y? Here I find here 1 and here I find here 2. That means the powers of y are not same. That means they are unlike terms. And I'll give you last example. Minus 5 x y minus 6 x square y, then 8 x y square. I have given here 3 terms. We're going to check whether these 3 terms are like or unlike. I find here xy, I find here xy, I find here xy. But even though, we have to check their powers. Here x power is 1 and here is 2. Here is 1. So by looking at the power of x, all of them, that means here x, here x, here x. For this x in all the terms, they have different powers. Some of them are having 1 1, but one of them is 2. Therefore, these 3 terms are unlike terms. So you should know how to identify like terms and unlike terms. This is so important because this will help you to add, to subtract easily. Okay, now let me tell you types of the algebraic expressions. But how do we divide them? We classify them on the basis of the number of terms. So if the algebraic expression has just one term, we call it monomial. If it has 2 terms, we call it binomial. If it has 3 terms, we call it trinomial. I'm just reminding you once again, all these things you have studied in the previous classes. Okay, and then quadrinomial. If it has 4 terms, we call it quadrinomial. Okay, shortly, if it has many terms, then we call it polynomial. And you'll study about the polynomial in the later classes, in class 9 and 10 properly. For now, you please know monomial, binomial, trinomial, quadrinomial, and there might be many more terms. Okay, I'll give you an example. Monomial means there should be just one term. Let me say 7x square. I give a single term, that means this is monomial. If I give you an algebraic expression having 2 terms, let me say twice xy plus 7y. One term, so 2 terms. Okay, so this is binomial. What about the trinomial? 6x plus 7y plus 9u. 1, 2, 3. So this is a trinomial. Similarly, if there is 6x square y plus 7xy square plus 8x plus 9y. So in this expression, how many terms? 1, 2, 3, 4. So this is what? Quadrinomial. In this chapter, you will study about addition, subtraction, multiplication, and division. Mainly, you will study these 4 operations in this chapter. Okay, we have the first exercise, that is 6.1, addition. Add 5x plus 4y plus 5z. And the second expression is minus 4x plus 7y minus 6z. And the last expression is minus 7x minus 4y minus twice z. We can do the addition in 2 different ways. The first one is horizontal method and the second is column method. But for now, in the beginning, I'll do the horizontal method. Okay, let's see how is it. Solution. What is the method? Horizontal method. Okay, first we'll write 5x plus 4y plus 5z. This plus, what is the next? We have minus 4x plus 7y minus 6z plus, and we have last expression minus 7x minus 4y minus twice z. We'll do. In the second step, let us open the bracket. So 5x plus 4y plus 5z plus into minus, you will get minus 4x plus into plus plus only. If it is plus, we'll not change any sign here. Plus into minus minus. So similarly, I'll continue here. Minus 7x minus 4y minus twice z. In the third step, in the next step, what we are going to do, we are going to club together the like terms. Here I find here x to the power 1, and any other term having x, here I find again x here, and the power is 1, and here there is one more term having x with the power 1. Okay, so we'll make a group here. So 5x, I'll bring this minus 4x. So when 4x comes here, even the sign should be coming. You should not separate the sign. Minus 4x should be brought here. And next we have minus 7x. This is one group. Next, I'll just put here plus, fine. This is 4y, plus 4y. So I'm putting plus 4y, plus 7y, 7y, and then minus 4y. Last we have 5z, and then minus 6z, then minus twice z. Okay, let's see. Out of these three terms, one term is positive and the other two terms are negative. So same thing, when I give you like 5 minus 4 minus 7, how can you do? You can write 5 minus 11, same thing, and finally you will get here minus 6. Similarly, I'll write here 5x, then here minus 11x. And what about this? 4y minus 4y, you can cancel, so that what you'll get here, you'll get here plus 7y. And what about the last one? I find here one positive term and the two negative terms. So plus 5z minus 8z. And then we'll get here minus 6x plus 7y. And then this is plus actually. From inside, what we'll get from inside the bracket, you'll be getting here minus thrice z. Then here minus 6x plus 7y, plus into minus minus, then here thrice z. Okay, we have the second question, that is question B. Solution. Let's write 8x square plus twice x plus 4 plus minus 5x square plus 6x minus 8, and the last expression we have minus twice x square minus 4x minus 7. Okay, now let us open the bracket. This is the beginning, that's why I will not teach you how to do shortly. With the correct process, let us go. 8x square plus twice x plus 4 plus into minus, you'll get here minus, so 5x square plus 6x minus 8 plus into minus minus twice x square minus 4x minus 7. Okay, so the first term is 8x square. So here the variable x with the power 2. So any other term having x and the power is 2, we have here one more, and we have here one more. So let us make together them like terms combination. 8x square minus 5x square, and then minus twice x square. I'll put here plus. Next, I find here x to the power 1. So twice x, any other term with x to the power 1, yes, we have here one more, plus 6x, and last we have minus 4x, minus 4x, and then we have constant term here, term without variable. So here 4, and here minus 8, and from here we have minus 7. Okay, so I can write here 8x square minus 7x square. Minus 5 minus 2, you'll get minus 7, of course. And then here plus twice x plus 6x, we have here 8x minus 4x. Then here plus 4 minus 15. Then we have here 1x square. So 1x square means you can just write x square. and then plus 8x minus 4x, you'll be getting here 4x. Then here plus 4 minus 15, you'll be getting how much? Minus. Then we have here now x square plus 4x plus into minus 10, 11.